Maybe it's 1 minute early, but then I can be talking that 1 minute while it actually just gets you back from lunch and back into the science mode. We got a wonderful walk around the global village. So that is indeed a nice place. Well, this afternoon we have 4 speakers, and we are starting out with my absolute favorite topic, namely mediation analysis. And the speaker is from Tsinghua University, Fan Yang. Floor is yours. I believe I have been able to spend the 1 minute such that get the up. I wanted to put the presentation slide up. This page, exactly, yes. So Fan Yang, professor at Tsinghua University, and as well as from Colorado, course analysis, mediation analysis, missing data, and in this talk, combining all of those 3. So please, the floor is yours.
Thank you very much for the nice introduction. And I'm very happy to have this opportunity to introduce my work here. Today, I want to talk about mediation analysis with a mediator and outcome missing not at random. Mediation analysis is a very widely used approach to try to understand the direct and indirect pathways through which an effect arises. And it has been increasingly adopted by researchers in many fields, including social science, epidemiology, and etc. But many mediation analyses are challenged by missingness in the key variables, such as mediator and the outcome. Here is a motivating study, the National Job Corps study. Job Corps is an education and training program for the 16 to 24-year-old disadvantaged youth who were disconnected from school and work. And it is the largest education and training program administered by the US Department of Labor. In the Job Corps program, those youth were provided very intensive education and vocational training with a goal to improve their economic well-being. And given that intensive educational or vocational training are the key elements of the Job Corps program, people are quite interested in study, for example, whether Job Corps programs' impact on earnings is mediated through educational or vocational attainment. And this National Job Corps study is an experimental evaluation of the Job Corps program, where people were randomized to either Job Corps program or to a control condition. And we used the data earlier processed by a group of researchers from UChicago, where here the Job Corps is randomized, as we mentioned, and the educational or vocational attainment was measured as whether or not a subject successfully obtained an educational or vocational certificate, which was measured at 13 months follow-up. And the outcome earnings is measured as the weekly earnings 4 years after randomization. Okay. The mediator and the outcome information were obtained through in-person interview. And as you can see from this table, there are tons of missing data. No matter under the treatment condition or under the control condition, the percentages of subjects who have both mediator and outcome measured were below 70%. And we are concerned that the missingness may be missing not at random, meaning that the probability of missingness may depend on not just the observed data, but also unobserved data. For example, let's think about the mediator, which measures whether or not a subject successfully obtained a certificate. You can imagine that perhaps for people who failed to obtain a certificate, they may be more likely not to report. So the probability of missingness of the mediator depends on the mediator value itself, which creates missing not at random. when data is missing not at random, it presents great challenge for causal inference because in such a case, the underlying data distribution just cannot be identified in general without further assumptions. And most of the previous literature assumes either missing completely at random by using complete case analysis or missing missing at random. And if you only have missing data in the outcome, Li and Zhou, Professor Xiaohua Zhou's work, they propose to utilize an instrumental variable type of covariate to identify the direct and indirect effects when the missingness in the outcome is missing not at random. And there, if you have a covariate that predict the outcome, but conditional on the outcome does not predict the missingness of the outcome. And if you also do not have missingness in the mediator, then this is the approach to go. But in general, when you don't have such a nice covariate, we still need some research in further exploring when and how you can achieve identification when you have non-ignorable missingness in the data. And in our work, we explored various interpretable missing not at random missingness mechanisms and try to understand when and how you can achieve identification of the NIE and NDE. Okay, this is the outline of the talk. I will first introduce the notation and some basic assumptions underlying mediation analysis. Then I will talk about the simplest scenario where you have missingness only in the mediator and you're worried that the missingness is missing not at random. And then I will extend the results and briefly talk about the identification results when you have missingness both in the mediator and in the outcome. And then I will talk about the application to the job corps study. Okay, we use T to denote the treatment assignment, which it equals 1 if it's a subject was assigned to the experimental group and 0 otherwise. And we use potential outcomes approach to define causal effects. We use MT to denote the potential mediator value under treatment condition T. And we use YT-MT or equivalently YT, given that M is in the pathway from T to Y. To denote the potential outcome value under treatment condition T, we use X to denote the vector of measured covariates and M and Y to denote the observed value of the mediator and the outcome. Those are standard. And the goal of many of the mediation analysis studies is to decompose the average treatment effect into a direct effect and the indirect effect. And here, ATE is decomposed into natural indirect effect and the natural direct effect. And besides Y1M1 and Y0M0 that we have defined before, another potential outcome or counterfactual outcome that is involved is Y1M0, which describes the potential outcome under the treatment condition had the mediator value taking its value under the control condition. And the natural indirect effect is the expected comparison between Y1M1 and Y1M0, describing the amount of change in the outcome under the treatment condition had the mediator value is changed from M0 to M1. And NDE is the expected comparison between Y1M0 and Y0M0, which quantifies it, the effect of the treatment on the outcome had the mediator value taking its value under the control condition. And you could see that this potential outcome under in red is never observable, and between Y1M1 and Y0M0, 1 is observable. So essentially, we are dealing with a missing data problem in a missing data problem. And we know that when you don't have missing data, the sequential ignorability assumption gives us the identification of the NIE and NDE, and this is the non-parametric identification results. Based on this result, when we have missing data, we could immediately realize that the key would be to be able to identify the following two conditional distributions. One is the distribution of M given T and X. The other one is the conditional distribution of Y given T, M, and X. Okay, now let's move to the simplest scenario where we have missing data only in the mediator and the missingness is missing not at random. Let's first think about what is MCAR and MAR. Let's use RM to denote the missingness indicator of M, 1 if observed and 0 otherwise. And for simplicity, we let all graphs condition on X, allowing X to have an impact on everything on the graph. And if RM is independent of everything, then the missingness is missing completely at random. And a complete case analysis is enough for us to obtain consistent results. And if the missingness is independent of the variable having missing data M, given Y, T, and X, then the missingness is MAR. We can also identify NIE and NDE given the observed data. However, as we mentioned in the job corp study, we are concerned that people who failed to obtain an educational or vocational certificate were less likely to report compared to people who successfully obtained an educational or vocational certificate. And therefore, we're worried that there might be an effect from M to RM, which creates non-ignorable missingness. Okay, now here is a proposed MNAR mechanism. We allow the missingness RM to depend on the missing value M itself. But because the outcome Y occurs later, so it's plausible in many studies to assume that the missingness of the mediator is just conditionally independent of the outcome given MT and X. So this motivates the following MNAR assumption 1, which assumes that RM is independent of Y given MT and X. Okay, now let's here I want to show you the idea of how and when identifiability can be achieved in a very simple scenario. Let's assume that everything are categorical. For the conditional distribution of Y given MT and X, it's trivial because RM is conditionally independent of Y given MT and X. So this part doesn't essentially just invoke or can be obtained immediately based on our missingness mechanism. So the key would be to be able to identify the conditional distribution of M given T and X. The idea here is that you have observable data stratum given M, Y, and R, M, right? In each stratum defined by given T and X. And we can link those observable probabilities with things that are unknown. And we obtain a system of linear equations where this ratios related to the probability of missingness given MT and X as unknowns. And the idea is that if those ratios are identifiable, then we can immediately identify the conditional distribution of M given T and X. So the question is when those ratios in blue are identifiable. Well, essentially, if the above system of linear equations has full rank, then we have identification. And this full rank condition essentially requires that first, the number of elements in the support of Y is now smaller than the number of elements in the support of M. And second, M needs to have an impact on Y given T and X. Now, more generally, you may have continuous continuous Y. So this full rank condition is generalized to this completeness condition. And this assumption of completeness is routinely made in in non-parametric identification problems. And it holds under some frequently used parametric models under some non-zero assumption on some of the model parameters. And this is our theorem 1. which gives us the condition of identification. Essentially, under sequential ignorability and under the MNAR assumption 1 proposed, if the probability of observing the mediator in each stratum defined by M, T, and X is bigger than 0 for all M, T, and X, and also if the joint distribution of ym rm equals 1 given T and X is complete in Y for all T and X, then you can identify the joint distribution of Y and M given T and X so that it leads to identification of the NIE and NDE. But an interesting observation is that because the distribution of Y given M, T, and X, it can be identified even without the completeness assumption. So in a special case where the completeness condition fails, that is when M does not predict Y given T and X, then you can actually still identify NIE and NDE, because once you have this conditional probability, M does not predict Y given T and X, so it equals the conditional probability of Y given T and X, and therefore NIE is just 0, and you can identify NDE the same as the ATE. Okay, recall that the completeness condition is a key for identification, and it essentially having 2 parts. One part is related to the supports of Y and M, and the other part is related to whether M predicts Y given T and X or not. So in our simulation studies, when we consider various different relationships in the supports of M and Y, and also consider scenarios M predicts Y or not. And in the methods comparison, we compare with complete case analysis, multiple imputation under MAR, EM algorithm, our EM algorithm, which incorporates the MNAR mechanism, and also we compare the methods with the Oracle one, where you know the true value of the missing data. Given the time constraint, I'm not going to talk about the details of the results, because when you have the completeness condition, everything, all the results are as expected. Our methods incorporating the MNAR mechanism perform as well as the Oracle one, except that it has slightly larger standard error. But the multiple imputation under MAR or complete case analysis, they all have substantial biases. But one thing that I want to point out in our simulation study is that when the completeness assumption failed to hold, then we cannot get non-parametric identification, right? But if you analyze the data using parametric models, and your data is indeed generated by those parametric models, the parametric assumption, it helps. But our simulation studies shows that the degree to which the parametric assumptions may help vary from cases to cases. There are scenarios that you can almost perfectly recover the true NIE and NDE, but there are also some scenarios where some parametric models or those additional parametric assumptions still give you a quite biased results of the NIE and NDE, and the distribution of the parameters may display multimodality and other irregular patterns. So the take-home message is that when non-parametric identification cannot be achieved and you impose further parametric assumption, we still need to be very, very careful. The parametric assumption may be helpful in some scenarios, but may not be helpful in some other scenarios. We still need to study those mechanism and assumptions case by case to see whether or not you can indeed achieve identification. Okay, now let's move to the more complicated scenarios where you have missingness both in the mediator and the outcome. Okay, we have another variable that has missing data. Let's use RY to denote the missingness indicator of Y. 1 if Y is observed and 0 otherwise. And here are the graphs. DAG shows MCAR mechanism and MAR mechanism. If the vector of missingness, RM and RY, is independent of everything else, then the missingness is missing completely at random. And if this vector is independent of the vector having missing data, M and Y, given T and X, then the missingness will be MAR. And still allow M to have an impact on RM and assume that Y is not going to affect RM. What's happening in the future are not affecting what happened in the past. Then we found that the identification of the NIE and NDE can be achieved under some completeness assumptions when RY only depends on one of RM or Y or M. Okay, now if you take a look at this MAR assumption 2, essentially it has the MAR as the, I'm sorry, it has the MAR as a special case. Okay, it has the MAR as a special case. And this one fits the scenario where, say, people who is not willing to report their mediator value is also more likely to not to report their outcome value. And this scenario is describing a scenario, for example, for people who, say, have no earnings, they are perhaps more likely not to report. And compared to the previous two, I think this one is perhaps the least plausible for our application study. It is saying that it is the M that drives the missingness in both M and Y given T and X. But when RY depends on more than one of RM, Y, M, say 2 of them or 3 of them, the identification of NIE and NDE cannot be achieved without further assumptions. Okay, now let me talk about the application results. The data contains about 8,700 subjects, and we've talked about the definition of M and Y. We have a lot of covariates that we can adjust for, which play the role as confounders between the M and Y relationship. And besides the missingness, another complication is that we have excessive 0 values. Our outcome is earning, and quite a skewed positive values. So for our outcome model, we adopted 2-part models. Okay, now we did the analysis under all of those missingness mechanisms, and also we considered the 2 different types of 2-part model, 2-part gamma and 2-part log normal. And you could see that the NIE and NDE, although the estimates vary, but the causal conclusions are quite robust across all the mechanisms. And it is the first one that stand out in terms of the log likelihood. And it corresponds to this missingness mechanism. Okay. To summarize, we show some positive results on non-parametric identification of the NIE and NDE when mediator and worthy outcome are missing not at random. And I want to end my talk with one of our favorite statistics quotes. If an issue can be addressed non-parametrically, then it will often be better to tackle it parametrically. However, if it cannot be resolved non-parametrically, then it is usually dangerous to resolve it parametrically. Thank you.
I have one. It was on there was, I think it was slide 18 maybe. You had all those simulation results. Just a feature that popped to my mind. Yeah, there we go. It's generally true across all of them, but it's particularly obvious for the lower left, where we see this with the indirect effect being seriously much more precisely estimated than the direct. We see that often. Do you have some feel for why it is?
Right. it is the case. But I'm also wondering for some other estimation strategies, for example, weighting, whether people also get similar pattern.
Well, the thing is, I have seen it both with a good and a bad reason. I have seen it just because there's extra information from the mediator, but I've also seen it a couple of times where it was something that you have over parameterized, put in too much structure somehow. So that was why I was a little curious to see it again.
Yeah, that's a very interesting observation. Thank you for pointing that out.
Then please join me in thanking the speaker again.